Welcome to this week's Lunch and Learn entitled Dr. Gitlove, How I Learned to Stop Worrying and Love Interactive Rebase. If there's one tool we all use that inspires a mix of awe and confusion, it's Git. We all have to use it, and we all manage to get ourselves into trouble using it. So, by popular demand, I wanted to talk about some of the ways to avoid getting into trouble in the first place and how to get out of trouble. The main tool in Git that we use when we're trying to figure out what's going on is the log. Now, there are a couple of different logs that we use in Git. The command git log will show your commit history. It'll show you a list of all the commits that have been made in your repository, who made them, and it'll give you an ID for each one called a SHA, which can be used by various other Git commands to refer to that specific commit. There are a wide variety of options that you can use to format your log so that it shows only the information you want, make it easier to read, and you can download the slides after this talk. There's a nice page on Git's site to tell you all the options that you can use to format it. Git ref log is a little more advanced than Git log. It shows not only the commits you've made, but every action you've made in Git. It shows when you've pulled down the changes from upstream, when you've pushed, when you've rebased. We'll get into that later. And you can use the ref log to back out of changes that you could not back out of using the log. For example, if you rebase a branch and you make a mistake, you can use git ref log to go back in time in Git before you made the rebase, figure out what you did wrong, and then go do it correctly. As I mentioned, each entry includes a SHA-1 hash that uniquely identifies that commit. And those will be referenced all over the place in this talk. They're very useful. First, I'd like to talk about pushing commits up to a remote Git repository. There are several commands to do this. Git push is the most basic one. Git push works if your local history and the history on the server are identical, meaning you've made commits, you've made merges, you haven't done anything to modify history. And if nobody else has pushed changes to the branch that you're trying to push, then git push will work fine. This is going to be the vast majority of the time, assuming nothing has gone wrong. Git push -- force release works if the local repository contains all of the commits that are on the server. It doesn't matter it'll work if you've made changes to the history in your local repository, as long as there is no work on the server that is not also in your local branch. Git push -- force release will successfully push your changes, including the history rewrites that you've made. When I say force push, this is what I mean. There's a stronger command, git push -- force. That always works. Don't ever do it. Don't ever do it as a star, because there actually are a couple of cases where you might want to do it. Those cases will generally only be to fix somebody else's problem that they've created by using git push -- force. Don't ever do it unless you really know what you're doing. Do not force push to the master branch or to the integration branch. I'm going to repeat that. Do not force push to master or integration. The reason you shouldn't do that is because when you do so, you can overwrite other people's work. Those master branch and integration branches should both be clean. They should have a continuous history. You shouldn't be trying to change history on those. If you're using GitHub, then there is a way to disable force pushing to those branches so that Git will actually reject any attempts to force push those. I would strongly suggest enabling that if your project and your team are using GitHub. I've been talking a lot about rebasing. What is rebasing and how does it work? The way rebasing works is it will rewind all of your work to a certain point, which could be a point that you chose, it could be the point at which you created your current branch. It will introduce some set of changes starting at the point that you selected. And then once it's made those changes, the rebase will replay all the other commits that are made on the branch, fixing any conflicts as they arise. So for example, if you rebase it, git pull -- rebase is the most basic example of this. That will bring in all the changes from the server that have not been applied to your local branch, but it will play the commits from the server back in order, and then it will play your local commits back in order. Therefore, if you made a change that conflicts with a change that is on the server, your local commit will be rewritten so that the conflict doesn't exist, which allows you to preserve a clean commit history. You should always do this instead of using git pull. Git pull will try to do the merge manually with varying results. When you say git rebase and you specify a branch, it will do the same thing as pulling from the server, except with whatever branch you specify. So say, for example, you're working on a feature branch, you have your integration branch. If you're in your feature branch and you type git rebase integration, it will pull all the changes from the integration branch into your feature branch, fixing the conflicts as they arise. Again, giving you a clean commit history, and giving you a feature branch that can now be merged into the integration branch with zero possibility of a merge conflict. And then the final type of rebase I'm going to discuss here is when you type git rebase -i and then provide a SHA. That will lead you through a series of prompts which allow you to make certain changes to the history of the branch that you're on. For example, you could change the commit messages. You could squash two commits together. And so let you fix some mistakes that can happen over the course of your development. It can also allow you to, for example, if you have a bunch of work in progress commits because you needed to commit when you were leaving for the day, you can squash those into the previous commits so that you'll have a clean commit history, and anybody who goes back and reads it will be more easily able to tell what you were working on. Here's a little diagram to show you how it works. Say you have commits A, B, and C on your develop branch, which is the name I'm using for integration here. You have A, B, C, and then you and your partner, you and your pair, made a feature branch, and you made commits E and G. And then some other team merged in their feature branch that contains commits D and F. Now, you have divergence. You have commits E and G, which are not in the develop branch, but the develop branch has commits D and F, which are not in your branch. There are two ways of resolving this conflict that people generally use. The first is typing git merge develop. What that will do is it will pull commits D and F into your feature branch and create a merge commit, the title will be something like merging branch develop into feature, which will fix all the merge conflicts, and any conflicts will be part of the separate commit. A cleaner way of doing it is to type, instead of git merge develop, type git rebase develop. What that will do is you have your pointer, will rewind back to the point at which the two branches diverge. It will play commits D and F from develop on top of your feature branch, and then it will replay your commits E and G after those two commits. And if there are any merge conflicts, you'll be prompted to fix them as they're applied. Once you've done this, you have a straight line going all the way through, and if you then switch to develop and type git merge feature, their merge will happen cleanly. There is no possibility of conflict unless somebody else committed code to develop in the meantime, in which case you need to rebase again. So that's a workflow for Git that will keep you from getting into a lot of trouble. If you do this, once everybody gets good at it, people will be pretty comfortable, and there's a pretty small likelihood that people will encounter merge conflicts that they don't know how to fix, which is one of the big complaints people have about Git in large teams. Now I'd like to talk a bit about staying out of trouble, not causing these problems in the first place. The first thing I'm going to suggest is when you're making a commit, instead of just adding everything at once, use patch mode. The command is here, git add -A, which adds all of the new files to be staged for the commit, but it doesn't actually add the contents of the files, it just adds the files. And then do git add -p, which will, for each hunk of a file, will prompt you whether or not you want to add that hunk. So for example, say you made changes in 3 different parts of a file. 2 of the 3 changes are relevant, but one of them is just a binding.pry or some other bit of debugging code. You can add the parts that are relevant, skip the binding.pry, and then you don't have to worry about editing the file before you make the commit. The second thing you can do is avoiding shared branches to whatever extent possible. You should generally have one developer or one pair to any branch. For example, a feature branch. If multiple pairs are working on the same feature, then each pair should make sub-feature branches, and you can have sort of a main feature branch that you merge into as you're working. This avoids a lot of merge conflicts. You can avoid stomping on each other's work, and it generally gives you less to think about when you're making your commits. The third thing to do is maintain an integration branch other than the master branch. The master branch is only for code that is actually in production. The integration branch is for code that has been completed but is ready to be deployed to your staging environment or to whatever your development environment you're using, but is not ready to go to production necessarily. It requires more testing. That integration branch can be used in continuous integration environments, hence the name integration, and common names for integration and develop. When you have one of these integration branches, keep it up to date, keep your feature branch up to date with it. Especially if you're on a team, once you get to have a team with many people, that integration branch is going to be updated pretty frequently. So you should just as frequently rebase your feature branch against the integration branch. As I had said before, rebase instead of merge, it creates a cleaner history. And if you're on a shared feature branch and you've created sub-feature branches, you should frequently rebase the main feature branch onto your sub-feature branch, and also occasionally rebase the integration branch onto the main feature branch to keep everybody's feature branches from falling too far behind. It's better to address merge conflicts as soon as they arise by rebasing, because there's less of a chance that you'll get a merge conflict and you'll think, this code is a week old, but I can't remember what I did a week ago. And so the more recent the code is, the more likely it is to be fresh in your mind, and the easier it's going to be to fix any conflicts that arise. And finally, make sure your Git practices are standardized across the team. This is very important just because when everybody has the same workflow, first of all, everybody's going to be familiar with the workflow, so if somebody makes a mistake, other people on the team are going to have more context on what happened, therefore be able to fix the problems. And second of all, if everybody's following the same practices, it's less likely that something is going to go wrong. That applies to Git, and it applies to a lot of things we do as developers. When bad things happen to good developers, because even when everybody does things right, somebody will make a mistake, somebody will type the wrong thing by accident, somebody may try to do something tricky and they didn't do it right. So when you have a problem, what do you do to fix it? Say you made a mistake in your most recent commit. Git has a great way of fixing this. You do git commit -- amend. After you've added your new code, it will, instead of making a new commit, it will add your new code to your previous commit. So you do git add -p, add all your new code, git commit -- amend, and then it will immediately, instead of creating a new commit, it will amend your previous commit. So it's as if nothing went wrong. It'll give you a prompt to edit the commit message if you'd like. You can say -- no edit if you don't want to do that. You can also say -- reset author if you want to. For example, say you committed as the wrong pair. You can reset the author and it will have the correct information after you amend. Say you made a mistake and it was not in the previous commit, but it was in a commit 4 commits ago. You can, instead of doing -- amend, you can say git commit -- fixup, and then provide the shot of the commit you want to change. Once you've made all your changes and you're satisfied with everything, type git rebase -i auto squash, and then a shot prior to that, and the git rebase will automatically move the commit back to where it should have been, right next to the one that you were fixing up, and it'll automatically squash those 2 commits together. So this allows you to go back in time and fix commits. The third example of amending sort of interactive rebasing is, say you had a test that only failed in your continuous integration environment. You couldn't get it to fail locally. When that happens, you're often going to have 20 commits that say, try to fix test, try to fix test, try to fix test, try to fix test. Looks terrible in your commit history. The way to fix that is to type git rebase -i, find a SHA that is older than the 20 commits that you've made, And then when you get the prompt for what to do with each commit, squash all the commits into one. Then you can have just either one commit that says try to fix tests, or even better, one commit that has the actual work you've done. This won't happen in the future because instead of making the 20 different commits, you'll have been amending the previous commit. So you're only going to have this. You're only going to have to make this mistake once. All of these changes, all of these types of rebasing and amending do modify the git commit history. So if you previously pushed and then you either amend or rebase an old commit, you're going to have to do a git push ---- force release in order to get these changes to go up to the server. The next big problem that people frequently have happen when they're attempting to learn, especially about all this rebasing, is you do a rebase, you make a mistake. If you haven't actually finished the rebase yet, you can do git rebase ---- abort, and Git will go back as if nothing ever happened. That's the safest way out. If you haven't done anything else since you've done the rebase, if you type git reset ---- or ridge_head, that's a special reference that Git makes when you do a rebase. So if that was the last thing you did, that will back up before the rebase. Again, as if nothing ever happened. Not quite as safe as ---- abort, but I've never seen this not work. When all else fails, that ref log that I talked about before is your friend. Find the SHA of a commit before you made the mistake in your ref log. Type git reset ---- paste in that SHA, and Git will back up to before the rebase. And again, it will be like nothing ever happened. Keep in mind that this ref log is limited, so if you've done a whole bunch of stuff and you want to try to back up, it's limited to a certain number of commits. So commits are various actions that appear on the ref log, so try to do this as soon as possible. Now the big problem, you're about to step way outside your comfort zone. A lot of this stuff gets pretty easy after you do it, but when you're first doing it, it's pretty scary. So say you're about to do something pretty scary. Do git tag _good. This will create a tag in your Git repository that you can refer back to later. Then do what you're going to do. Rebase, squash 20 commits, do whatever you need to do. And if anything goes awry, you can say git reset ---- known_good, and you'll be back to the known good point. Very easy. The thing to keep in mind with this is if you've already pushed if you've made a rebase and you've already pushed it to the server, if you then try to back up before the rebase and push again, git push ---- force release won't work. This is one of those cases where you have to use git push ---- force. So don't get into that situation. Don't push until you're sure your rebase is good. Anyone have any questions?